All right, this video we're looking at Unit 3B, putting numbers in perspective. And in this one, we're going to look at an idea of scientific notation and making estimates and looking at scales and those type of things. So first, just wanted to start off with just a little bit of information here. So we hear numbers. We hear them in the millions, billions, and sometimes even trillions nearly every day, whether you're talking government spending or memory storage on a phone or computers. You hear gigabytes, terabytes, megabytes. But actually, relatively few people understand what these large numbers actually mean. And so, in this unit, we're going to be looking at some techniques for putting together large or small numbers into perspective so they get some real meaning. And working with large and small numbers is much easier when we have a special format, and that format is going to be called scientific notation. Okay, and kind of the key idea with scientific notation is we express each number in a form, or in this form, by writing a number between 1 and 10 and then multiplied by a power of 10. So for example, 6 billion in scientific notation would be 6 times 10 to the 9th. Or 420 in scientific notation would be 4.2 times 10 to the 2nd. And we're going to go over some examples, and then 0.67 is 6.7 times 10 to the minus 1 power. So positive exponents, so I guess you could make a note, if it's positive, you are going to be moving the decimal to the right. If it's negative, you're going to be moving that decimal to the left when you do powers of 10. Okay, so there's your formal definition of scientific notation. Okay, it makes it really easy to write large and small numbers. However, you got to be careful and not let it be deceiving, because if you were to try and look at this number right here, 10 to the 80th power, that doesn't look too scary, but it's actually humongous, larger than the total number of atoms in the known universe. You type that in the calculator and you're automatically going to get memory overload error. So it makes them look kind of small, but they can actually be really large numbers or really small numbers too. So what we're going to do is we're going to convert some of these numbers from scientific to ordinary notation and then write its name. So for this first one, 6 times 10 to the 4th. So what's that's going to do is it's going to take the 6, so technically your decimal would be right here, and you would move it 1, 2, 3, 4 places to the right. And notice that that gives us the number 60,000 in English. So 6 times 10 to the 4th is 60,000. Okay, the next one, B3 times 10 to the 5th. So again, you're going to move that decimal place 1, 2, 3, 4, 5. Okay, and if we look at that number right there, it looks like there should be a comma there, so that is 300,000. So you can write 300,000 as 3 times 300,000. You can write 300,000 as as 3 times 10 to the 5th. Now, very similar to that, 3.4 times 10 to the 5th. Here you'd have 3.4, and you're going to move that decimal 1, 2, 3, 4, 5. Excuse me, 3.4 times 10 to the 5th. Yeah. So then we'll fill in our decimals here, and this is going to be 340,000. Okay, so again, if you're timesing by a power of 10 raised to a positive number, you're moving the decimal to the right. However, once we jump down into problems like part D, okay, 2 times 10 to the minus 3, so you have 2, and here's your decimal place, and to the minus 3 goes 1, whoops, held it too long, 1, 2, 3 places. So you actually get the number 0.002. I guess I could write that out a little bit better, 0.002. Okay, and now in English, how we would write that out is that is 2, and remember the first place is the tens, the tenths, the hundredths, and the thousands. So that's 2 thousandths. And that's what 2 times 10 to the minus 3 would be. Okay. Similarly, on E, if you have 6.7 times 10 to the minus 2, you take 6.7, and you're going to move it 2 places to the left, so you'll get 0.067, and that is 67. And then again, we are 3 decimal places down, so that's in the thousandths position. Okay, and then now we're going to get into the really small. So this is 3 times 10 to the minus 6. So I'm going to throw my 3 here. And you have to go 1, 2, 3, 4, 5, 6. So you're going to get 1, 2, 3, 4, 5, 3. And that's down into the, so you got to count, so you got to go tens, hundreds, thousands, 10,000, 100,000, millionth. So this is 3 millionths is what 3 times 10 to the minus 6. 10 to the minus 6 is a commonly known one. It's on the micro scale. Micro is 10 to the minus 6. The nanoscale is on 10 to the minus 9. And those are some terms we hear, microtechnology, nanotechnology, and so forth. But that's looking at converting from scientific notation to just kind of our ordinary notation that we use and the names of those. And so being able to convert those back and forth is key. But just remember that it's always a number between 1 and 10 times 10 to a power. So if you have any questions on that, let me know. Let's look at this one right here. So we're going to rewrite the following statement using a number in scientific notation. So we talk about hard drives in computers or phones or whatever the case may be, and it says my hard drive has a capacity of 1.2 terabytes. And remember that a terabyte, so tera means trillion. That was from an earlier lesson in one of the tables. And so we want to know how would we write that in scientific notation. Well, so again, terabytes is in the trillion, so that would be, if I were to write this number out, so that's going to be billions, millions, thousands, and then hundreds. So it's going to be 1.2 times 10. It's going to be a positive power because all those zeros. You're going to think how many times I'm going to have to move this decimal. So if I were to start here, it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you have 1.2 times 10 to the 12th. And now the units here, instead of terabytes, this would be down just to the standard unit of bytes. So 1.2 terabytes is the same as 1.2 times 10 to the 12th bytes. And that's how we'd write 1.2 terabytes in scientific notation. And then here's our standard notation into trillions. Okay, so that's looking at scientific notation. Okay, next we're going to be looking at this idea of trying to put things or numbers into perspective using estimation. And so when we try and put things into perspective through estimation, sometimes you might say, well, that building is 1,000 feet tall or whatever. So in this case, we've got, how high is 1,000 feet? Because for a lot of people, this quantity of 1,000 feet doesn't have a whole lot of meaning. And so we can give the number some perspective by estimating what it would be for a tall building. So, for example, we can expect each story in a tall building to be about 10 feet from floor to ceiling, which means 1,000 feet is the approximate height of a 100-story building. So now, we take it from feet to stories, so that might give it a little bit more meaning to you. Now remember that these things aren't always exact. For example, the One World Trade Center, which is right over here in New York City, has a roof height of 1,368 feet. It's 105 stories, so it's about 13 feet per story. So our estimate of 10 feet per story was off by about 3 feet or 30%. However, if we have no idea what 1,000 feet looks like, picturing a 100-story building, it gives us a reasonable sense of what it means. And so when you're trying to estimate, you're trying to bring it into terms of something that makes sense to you. Another way that is commonly used is people will measure large quantities of feet to like football fields. And so 1,000 feet would be just a little bit more than 3 football fields, because a football field is 100 yards or 300 feet. And so we use these ideas to change our perspective, to put it to be able to gather estimations that make sense to us, or a little bit more sense. So, and so I'll leave the rest of that there. I put this one little historical note over here. One World Trade Center, which is that building right below. The roof height is identical to that of the original World Trade Center's North Tower, which was destroyed on September 11, 2001 in the terrorist attacks. And above the roof, there's a spire, so you can see the little spire right up here. And that spire rises up to a height of 1,776 feet, which is symbolic of the Declaration of Independence, which was signed in 1776. So, sometimes the numbers of some things do have meaning behind them. But I just thought that was an interesting thing as we talk about the perspective of heights of building and such, the history that's in there. So that's tying in a little history with math. So we're going to look at doing some estimations in our next video.